All right, we're going to continue on today with logarithms. Today we're going to just focus on solving logarithm equations and inequalities. So what that looks like is like example 1 here, where I have a log base 9 of x is equal to 3 halves. So we're trying to solve this for x. One of the easier ways to do this would be to turn this into exponential. So this is the same thing as 9 to the 3 halves is equal to x. Okay, so I would rewrite that as 9 to the 3 halves is equal to x. Now there's actually two ways that we could solve this once we know that. We have this fraction here. We know that that fraction means the same thing as taking the, so whatever's in the denominator, remember that's the root we're taking. So the second root of 9 to the 3rd power, okay, or we can write this as 3 squared. So I just wrote the 9 as 3 squared because it's a perfect squared. 3 squared to the 3 halves equals x. And we know that when we do this, we take a power to a power. 2 times 3 is 6. 6 divided by 2 is 3. So this is the same thing as 3 to the 3. Both of these strategies will give you 27 in the end. Okay, so if you typed 9 to the 3rd power into your calculator and then took the square root of that, you'd get 27. If you took 3 to the 3rd power, you'd also get 27. Just wanted to show you both of those. So on 1b here, same deal, right? So, and I encourage you to try this one on your own. Make sure you get these in your notes. We're going to take 16 to the 5 halves, set that to equal x. Okay, so 16 to the 5 halves equals x. And I'm going to do it this way where I change that 16 to 4 squared. Okay, when I multiply that out, I get 4 to the 2 times 5 is 10. 10 divided by 2 is 5. So I get 4 to the 5th is equal to x. Therefore, x is equal to 1,024, I believe, when you punch that into your calculator. So that's example 1. Then we get into this property of equality for log functions. So basically, if you have a logarithm that has the same base, so that's key here. Okay, same base, log base 5 in the example, log base 5 in the example. What we can do here is we could drop those logarithms. So we can just say, okay, well, x must be equal to 8. Like whatever's here has to equal this if the log bases are the same. So that's what this is saying for the property of equality. So you get that into your notes. However you want to do it, I would just probably put the example in there, but you could also use this example. Anyway, example 2, here we go. Let's solve one of these. This is a little more complex than that example. So notice we have the same log base. Okay, so if we have the same log base of something on either side, I can drop those logarithms and just say, okay, x squared minus 15 is equal to 2x. Now, how do I solve this? Well, this is a quadratic, so I'm going to have to factor it, okay? And one of the big takeaways, I'm going to pause the lesson right here for a second. One of the big takeaways for today is that when you have, you know, a log base of a positive number, which that's all we deal with, if you could take that to some power, doesn't matter what the power is, you will always get a positive. You'll always get a positive number out. So here, when we do this, we're going to get, there's a possibility that we're going to get a negative factor. We do not include the negatives because we can take 3 to no power to get a negative answer. You can try that all day on your calculator, but that's not going to happen. So that's just a preview. That's very important to some of the remaining topics here that we have in this chapter and in this lesson. So remember, this has to stay positive. So x squared minus 15, let's actually write this as minus 2x minus 15. So I just move the 2x over. Okay, now I ask myself what multiplies to give me negative 15, adds to give me negative 2. And the two things that work there would be, let's see here, if we did negative 5 and positive 3, that should give me that 2, right? So negative 5, positive 3, so we have x minus 5, x plus 3. And what makes these go to 0 would be my solutions, right? So 5 and negative 3. Now, I just got done saying that these can't be negative. If I plug a negative 3 in for x here, this becomes a negative 6, and that does not work. So I cannot include negative 3. 5 does work when I plug it in to either side. I get 10 on that side, and on this side I would get, what is that, 25 minus 6, so that's 10 on this side, right? So hopefully you do get the same thing there since they're equal. So the answer here is H. Okay, so the property of inequality for log functions. all this is saying is that, as long as we have b greater than 1, x greater than 0, okay, standard logarithm stuff, then if I have a logarithm of something that is greater than y, then the alligator continues, what I want to highlight here is that the alligator continues to have the same relationship with x. Okay, so notice that the alligator is eating the x in the original logarithm here, and it is here as well in the answer, right, when you go to solve it. Same is true the other way, so when it's less than here. But then, if we're saying that this logarithm is less than some value, okay, if we're saying it's less than some value, we have to, as I just got done saying, we have to make sure that it doesn't go negative, so we have to also include this idea here where it's also greater than 0. Okay, so whenever you see a less than, you got to make sure you limit it so that it can't go negative. That's important takeaway from this property of inequality for log functions. So here we go on 3a. If you're going to set this up like you typically do, it's 4 to the third is equal to x, right? So 4 to the third, but I'm not going to say equal to. In this case, the inequality is saying that the x value is greater than. So the alligator has to continue to eat what it's eating there, so it would be the x. So I'm going to do this. So notice this switched because of how I wrote it, right? Just because of how I wrote it. If I would have wrote it out the other way and put 4 to the third on the other side, then things would have stayed the same. But just because of how I wrote it, the alligator is doing the same thing that it was doing in the original. Now I can solve this, so I get 64 here is less than or equal to x. Okay, so since the logarithm is bigger than something, I don't have to worry about limiting the negative. So my final answer here is x values where x is greater than or equal to, notice how I flipped it back, 64. Because I like it in this form where the x is first. Okay, alligator continued to eat the x, right? I just flipped it back. Okay, let's do another one here for this one. Notice that the logarithm now is less than. That is crucial. So we have 2 to the fourth. And then since the x here has the alligator is eating that 4, it's going to go this way. Okay, so when I do that out, I get, let's see here, I get 16, I believe. So 16 is greater than x. So when I go to write my final answer here, notice that the logarithm has to be, if it's less than some value, I also have to make sure that it doesn't go negative. So for my final answer, I'm going to say the x has to be bigger than 0, but then it's also less than 16. Okay, so just be careful on those less thans. I know that's a little confusing, but this cannot go negative. So I have to make sure that that x value stays between 0 and whatever this is telling me. Okay, so another property of inequalities for log functions with the same base is that if you have the same base on either side of an inequality, we can drop the logarithm. Okay, so that makes it pretty nice. Here, in this case, it would just be x has to be greater than 35. I want you to notice something, though. If it was the other way around, if we had log base 6 of x is less than log base 6 of 35, these would still cancel. I would still get x is less than 35, but then I would have to say, okay, well, if this x value is less than 35, I still can't have a negative here. Okay, so since I can't have a negative, I have to make sure that I keep my answers positive. So I can plug in anything from, just over 0 to 35, anything bigger than 0, and under 35 I could plug in to make this inequality true. But sometimes, like in example 4, well, I'll explain it when I get to it, but let's do it. So we have this logarithm here that's the same on both sides. It's log base 5, so we can drop those. We get 2x plus 1 is less than or equal to x plus 4. Okay, so when I solve this, I can move my x over, I can move my 1 over, and I get x on this side is less than or equal to 3. But you would be wrong if that's what you leave as your answer. You're not fully right yet, because this cannot go negative, this cannot go negative. Okay, they cannot go negative because 5 to some power will never give me a negative number. So now I have to limit it. I have to make sure that neither one of those go negative. So what would make this one go negative is negative 4. So I know that x has to stay bigger than negative 4, but let's see what makes this other one go negative. So if I'm looking at this one here, and if you don't know what makes it go negative, just set it to equal 0. So I can say, okay, 2x plus 1 equals 0. Let's see at what value that starts to go negative. When I do this out, I get 2x equals negative 1. X is equal to negative 1/2. So if I plugged a negative 1/2 in there, I'd get a 0. And I know I can't get that 0 or anything below that 0. So I'm going to say that this x value, since this one is the bigger of the two that I restricted, this x value has to stay between negative 1/2 and 3. Okay, there's a limit to how low x can go. Since x is less than 3, 2 would work, 1 would work, 0 even works. But once I get down to 1/2, negative 1/2, it no longer works because then the logarithm becomes a negative, and there's no, like I said, 5 to what power gives me a negative number? Good luck finding that. There's nothing you can plug. Even if you did 5 to the negative 100, that's still going to be a positive answer. It's just going to be a really, really, well, since it's to the negative, it's going to be a really, really, really small number. Okay, so keep that in mind, you guys. This can never go negative. Never go negative. I think that's it for this time. We'll catch you guys next time.